Welcome everyone. Hi everyone, and welcome to our webinar live RAG comparison test. Pinecone versus Mongo versus Postgres versus SingleStore. My name is Yukti Divedi and I'll be your moderator today. One of my main jobs at SingleStore is to organize weekly AI webinars. We organize 2 webinars per week and we demonstrate data and AI use cases and new tools and technologies. Also, I post about our upcoming webinars every week. So if any of these topics are interesting to you, please feel free to connect with me to stay on top of the loop. Also, I'd like to hear your feedback or ideas or any criticism that you have on topics that you'd love to see in future sessions. So please feel free to connect with me and drop a message on LinkedIn. Speaking of future sessions, we have got several informative new webinar sessions coming up. On 15th, we have Zapier Central, SingleStore, full RAG agents. I'll put everything in the chat so that you can just see and access easily. On 16th of May, we have Beginner's Guide to RAG with Professor Tom Ye. And on 22nd of May, we have LLMs in fraud detection, model comparisons. I'll be putting the links to these in the chat. And if any of these topics are interesting to you, please RSVP right now. I'll hope to see you all there. We have amazing experts coming, so you don't want to miss this definitely. Okay, coming back to today's topic, you're welcome to participate in the discussion using the Zoom Q&A button, which you'll notice at the bottom of your console. We have an internal mission statement to try to answer 100% of audience questions. And even if that means following up with folks afterwards via email, this has actually gotten a little difficult over time because sometimes we have thousands of registrants and hundreds of questions, but we are absolutely up to the challenge. Please ask away and make sure you have logged into the Zoom account with your actual name and email address because we won't be answering any anonymous questions. I hope that's understandable. Okay, so we'd also love you guys to have a dynamic experience during this webinar. So please feel free to try out SingleStore notebooks. Anyone who tries it out today will be entered for a chance to win either brand new branded AirPods Pro or Meta's new Ray-Ban LLM smart glasses. It's absolutely your choice, whoever wins. Simply click a link that everything I'll be putting in the chat to enter the raffle and log in. You may know that SingleStore has had a free trial offer for many years, but just in the past few weeks, we have also announced a new free share tier, which we'll talk about a bit later today. Okay, moving forward, allow me to introduce our amazing speaker today. We have the real database expert today, Rohit. Rohit is a cloud solutions engineer and is a great asset at SingleStore, where he works with customers to design, deploy, and optimize cloud-based data solutions using our unified database platform. Additionally, he's also had research experience from UC Davis, which is super cool, by the way. We're so happy to have you here as a speaker today. Welcome, Rohit. The floor is all yours. And yeah, let's get started. Thank you so much.
Awesome, awesome. Thank you so much, Yukti. Let me go ahead and share my screen. Just need to figure this out. Okay, let's try this. Awesome. So today we are going to essentially run a comparison between SingleStore and a bunch of very popular database vendors, and we've classified each of these vendors into, different buckets, and we'll talk a little bit more about that later. So let me go ahead and I believe Yukti, you've already covered these slides, so I'm going to skip over them. So let's go right into the information. So, Gen AI has really exploded in popularity over the last 1 or 2 years. And the reason is that everybody wants to be able to chat with their data. That's a very popular case that we've seen. Now, there are a couple of different types of applications as they've been classified by the industry. The first is your data application. This is what we like to call an information retrieval application. So for example, if you go to the SingleStore website and you take a look at our Squirrel bot, that's an example of an information retrieval application. You have your end user who's asking a question. The information based on that question is retrieved and sent to the user in natural language format by an LLM. On the other hand, you have your agentic application. So this type of application essentially will execute a task for you. The classic example is schedule an appointment for me. The LLM will take that, it'll take that information, it'll analyze your calendar, the person you're trying to meet's calendar, and schedule an appointment between you two. So this is another type of application that people are trying to build. And of course, these are all very, very useful and very achievable with LLMs. Today, what we're going to be focusing on are the data applications, the information retrieval applications. So let's take a look at the architecture that we will need for such an application, given the modern tech stack. So this is essentially how people have been implementing their RAG applications, their retrieval augmented generation applications. So on the one hand, you have your OLTP systems, you have your OLAP systems, and now because you're vectorizing your data, you have your vector systems. So these three in combination will provide the full context to your LLM. Let's take a look at how they do that. So on the left-hand side, you have your end user who will be asking a question. That question will go to the GenAI application. It will be vectorized based on the embedding model that you've used to vectorize your data. And that vector will be sent to the vector database. In the vector database, you'll perform your vector search, and that will retrieve your top K results. Let's say your top 10 results. So those results, along with the associated metadata, for example, an ID, will be retrieved from your OLAP and OLTP systems. Then, based on the user question, you will add more filters for the ID and so on, and that will then be sent to the LLM as a prompt. The LLM will analyze the data, and it will send a natural language response to the user. Now, all of this will require, I would say, a fairly complicated architecture. You'll need to be able to go to your vector system and perform a vector search. You'll need to get the relevant data from your OLAP and OLTP systems, your transactional and analytical systems, and you'll need to be able to stitch the responses together in a reliable manner. So let's go ahead and ask ourselves, what do we need from our database in order to build these applications? So there are a couple of points over here that I have listed. You will need reliable storage. You need efficient analytics. So you will also need to be able to store all of your data and retrieve your data in a highly performant manner. You need your data to be consistent across all of your systems. Of course, you will need a vector capability in your systems, right? You need to be able to search through the vectors and return the vectors in a very, very quick time. And finally, as your application grows in popularity, as it gains adoption, you'll need your application to be scalable and concurrent. So these are the main tenets that we see within the data application landscape. This is what you will need. So let's go ahead and take a look at who are some of the big players that you may consider when building these applications. So there are three main categories that we've bucketed these players into. You have your pure vector databases. You may have heard of some of them, such as Pinecone, Milvus, and so on. You have your vector-capable NoSQL databases, such as MongoDB, Atlas, and so on. And finally, you have your vector-capable SQL databases. So in this case, SingleStore would fall under this category. But another very popular example that we've seen is Postgres. So let's go ahead and analyze what each of these databases do and why they're a good or bad fit for your application. Before that, actually, let me explain a little bit about SingleStore, right? So SingleStore is a data platform in which you can transact, analyze, and contextualize your data in real time. So again, these are the three core tenets of SingleStore. When it comes to transactions, you can bring in your data at the scale of millions of records per second in a highly parallel manner. This is through a native function called SingleStore pipelines, but also you can use SingleStore's native connectors to write directly from your application. But the reason why SingleStore is able to scale up to that volume of data essentially is because we are a distributed SQL database. So we are horizontally scalable. The second piece is the analytical piece. So SingleStore allows you to perform analytical queries over petabytes of data. And since we support many different data models, you're not limited to just your relational data, but you can also query your geospatial data, you can query text data, JSON data, and so on. This enables you to do unstructured data analytics at scale. And the final piece of SingleStore, of course, is the vector capability. So within SingleStore, you can perform your semantic search, but since you also are allowed to, do text search, you can combine those two together. So you have your semantic search and keyword search together in one place, in one single query. That's what we like to call a hybrid search. We also have a cool feature called SingleStore Notebooks. And again, I encourage you guys to go sign up and try this out for yourself. So that's kind of a little bit of background on SingleStore, but let's talk a little bit about where we came from. So SingleStore was founded in 2011 as MemSQL. And to talk specifically about our AI features, in 2017, this is way before any of the Gen AI stuff was around. In 2017, we added support for vectors and semantic search. So what does this mean? SingleStore has supported vectors and semantic search since 2017, so they live within our ecosystem as first-class citizens. We have native functions for dot product and Euclidean distance for a whole suite of other functions supporting our vector capabilities. So vectors truly live within SingleStore as first-class citizens. And in 2024, in the SingleStore Pro Max release, we released ANN, approximate nearest neighbor indexing, and a compute layer. So essentially what this means is now, instead of being forced to run an exact k-nearest neighbor search on your vectors, you can speed up your response times in your vector search queries by orders of magnitude. So that is a little bit of background on SingleStore. So the question now is, why should you choose SingleStore to build your Gen AI application? And it boils down to three main points: speed, scale, and simplicity. With SingleStore, like I mentioned, you can perform your vector search co-located with a full text search or any other type of analytical search. And this can be done in millisecond response time. So you get fast hybrid searches with SingleStore. At scale, you can do this across petabytes of enterprise data. So you can scale from the gigabytes to the petabytes scale as required. And finally, SingleStore is standard ANSI SQL compliant. So you can query your data in simple SQL syntax. So it supports all of your data to transact, analyze, and contextualize in real time. So let's take a look at retrieval augmented generation with SingleStore. So this is a very similar architecture to what you saw before, but now you have all of your transactional data, all of your analytical data, and all of your vector data co-located in one single source. So now when your end user asks a question, the Gen AI application will vectorize that question. And within a single query, you can do your vector search, you can do your full text search, or any other type of analytical filter that you may want with millisecond response times. And you can send all of that to the LLM as context without any need for stitching your responses together. So a simple example of what a hybrid search would look like in SingleStore is something like this. So this is an example of a hybrid search query. On the left-hand side, you have your simple semantic search, where you're simply doing a dot product between your input query vector and the embedding that you've stored in your SingleStore database. And the right-hand side, you can see you're doing your vector search, of course, but that is co-located with a bunch of other analytical filters. So this is the type of query we're going to be implementing today. And we're going to be running that comparison across some very popular vendors that we've seen in the field. So let's analyze the capabilities of each of these. The scenario that we have is we are going to perform 250 concurrent hybrid search queries on each of the listed databases. So the databases that we're going to see are SingleStore, Postgres, Mongo, and Pinecone. So let's take a look at specialty vector databases. So what I'm going to do right now is I'm going to go ahead and run this immediately. So this is our concurrency test, and I'll explain a little bit about what we're doing afterwards. So when it comes to speed, for your vector searches, your specialty vector databases are fast. I can say that myself. I've worked with Pinecone. I've done research on them. They are fast, right? They do your vector search with millisecond response times, just like us. And they scale up to millions, to billions of vectors relatively well, right? So all of this is capable. Your vector database is definitely capable of doing this. But since they only store vectors, you'll require other databases, right? So the reason why is, of course, they allow you to store some metadata alongside the vectors, but with certain popular vendors, we see that you can only store on the kilobyte scale of metadata per vector. So this is not exactly scalable when you want to store a lot of metadata alongside your vector and you want to do filters on that metadata. So in order to bring your data into a single location, you'll require ETL tools in order to run those filters. So the questions you can start asking yourself now are, what about all of your other databases, right? Can they keep up? Can your application architecture scale? The key point that I want you guys to remember here is that you're only as fast as your slowest component. So if your application architecture is slow, even if your individual database instances may be slow, then your application is going to be slow. And so when it comes to this, where SingleStore really shines is simplicity, right? All of your data is co-located in one place, and all of it is highly performant. You can perform your vector search, your analytical filters, other types of queries with millisecond response time. So let's take a look at the demo. So what I've done is I've implemented a hybrid search using Pinecone as my vector database and using Mongo as my document database. So what we're doing over here is essentially we are doing a vector search in Pinecone, pulling the resultant vectors, and we are basically pulling the associated paragraphs from Mongo. And we implement our hybrid search where we are giving a combined score between the vector search and the full text search that we've done over here. So as you can see, this is taking quite a bit of time to run. It's been running for about 2.5 minutes and we still haven't gotten the results. Now, this notebook over here is running as a proxy for the ETL tool that we would run. And, just given that this notebook is running over here, you can see that this application is going to take a very, very long time to return any results. So I'm going to go ahead and kill this. But essentially, you can see that this is going to take quite a bit of time to run. And that's not on either of the databases you see here, but it's just on the application architecture that you've needed to implement just because of the fact that you couldn't store all of your data in one location. Awesome. So what did we learn here, right? With your specialty vector database, you weren't able to scale your architecture to run these 250 concurrent queries. How does SingleStore match up? Well, when it comes to SingleStore, you can do your contextually rich use cases because you're combining your vector data alongside all of your other kinds of data. So you didn't need to have that fragile application architecture in order to be able to run your query. Because of that, because you didn't need to provision more compute resources just to make sure your application architecture keeps up, it's less expensive, less compute hungry. And again, we're ANSI SQL compliant, so it's very easy to interact with SingleStore. Okay, so I'm going to move on, but there are a couple of other points that you can note that are on the screen. So let's take a look at vector-capable NoSQL databases, right? So again, vector-capable NoSQL databases are very good at transactions. They scale very well to the millions of events per second scale, and they're schemaless. So you can get your data in very quickly, and it's very simple to use. However, they have poorly performing analytics, and we've seen this, and we've actually built something called SingleStore Kai to address this. We know people who are building applications, they're not willing to immediately rip and replace all of their data stores. So if you're interested in augmenting your current databases with SingleStore, we've built something called SingleStore Kai. But because they have poorly performing analytics, having a NoSQL database requires you to build in a caching layer. For example, we've seen many of these in-memory databases being used alongside these NoSQL databases in order to run the analytics. So the questions that you have, again, run on the same thread. So what about the price as you scale, right? How are you maintaining all the other databases? Do your ETL tools scale? Does your application architecture scale? All of that kind of hits the same points. So let's go ahead and see where SingleStore can really shine. Again, like I said, across the millions of vectors across the millions of rows of data scale, SingleStore will perform your analytics in millisecond response time. This is something we've seen. It's tried and tested for many, many years with SingleStore. So SingleStore has your highly performant analytics and your highly performant transactions. So you don't really need to go to another location for that. So let's go ahead and check if my kill command has actually worked. And yeah, okay, it has. So let's go ahead and run the concurrent queries in Mongo. Oh, sorry, I'm going to need to run some of these cells again. So please forgive me. Let's go ahead and run this. Awesome. So let's take a look at our vector search in Mongo. So first we find the query vector that we've assigned, and this is what the Mongo search is going to look like. We have our vector search, we have our full text search, and we have our custom score calculation. So I'm going to run that. And let's go ahead and run our concurrent queries. You can see this is taking a little bit of time, but took about 7.3 seconds, 0 failed queries, and it executed the 250 concurrent queries. That's pretty good, you know, in comparison to what we saw with the previous example. Being able to do that in about 7 seconds is pretty good. Now, let's go back to the slide deck. So again, what did we see, right? Mongo did pretty good in 7 seconds. But imagine you go to your chat application and you type in a question, right? You have to wait 7 seconds for your chatbot to even begin formulating a response, right? That's just when the context is sent. By the time you're actually done getting an answer from your application, you may be looking at something like 10 to 15 seconds. That would be a very difficult to get people to stay on that page when that happens. So essentially, that's where SingleStore comes in, right? You can run your queries with your millisecond response times. We have vector capabilities that have been proven in production use cases. And again, since we have native JSON support, you can actually query your JSON data if that's how your vector data is stored. And like I mentioned earlier, we have SingleStore Kai to speed up your JSON analytics. If you don't want to bring all of your production data into SingleStore, SingleStore can just sit on top of your NoSQL database and speed up your analytics. Awesome. So let's get into the last kind of bucket of database that you see. This is a vector capable SQL database. And you know, the one we're going to be looking at today is Postgres, right? So when it comes to speed, again, your vector capable SQL databases are fast, right? They're very performant. And again, they can store all types of data. This is very similar to the SingleStore story, right? You can have your vector data co-located with your text data, with any other type of data you may imagine. However, when it comes to these databases, they don't scale very well, right? Besides SingleStore, we've not really seen many other databases do separation of storage from compute, right? Or separation of compute from compute. So all of the different operations that you're running in your database are going to be competing for resources. So that's where you can start asking yourself questions like, will I have performance bottlenecks as I scale my application up? How will my price to performance ratio evolve as my application evolves, right? How am I going to get the data into my database as well, right? Are my transactions performing as I want them to? Will I have to MacGyver my way into a simulation of a distributed architecture? How do I maintain data consistency across all of the different instances that I may be running? All of these are questions that you can ask yourself. And at the end of the day, you're still going to need multiple databases, either having a transactional database to bring in your transactional data or having multiple instances of the same database. So again, that's where SingleStore comes in with our scale up and scale out architecture. Essentially, you don't have to worry about this. It's all managed for you. SingleStore can handle all of your transactional and analytical requirements. So let's go ahead and take a look at the vector capable SQL database demo. And we're going to be running Postgres locally here. So I'm going to run that, and let's go and test our queries. You can see we're running. Okay, 250 concurrent queries. Took us about 4.3 seconds to return the results, but you saw we have 151 failed queries. So what this means is about about half of your users, maybe more than half of your users, are going to be essentially getting no information back from your LLM application. So this is obviously not what you want to see from your Gen AI application, especially as it scales to meet these requirements of 250 concurrent queries. So again, taking a look at where SingleStore plays into this. SingleStore is a distributed SQL database for your scale-out vector data sets, right? So if you need high concurrency, if you need to handle millions to billions of vectors, this is where SingleStore plays a perfect role. You don't need to worry about having multiple instances of your databases. All of that is handled on SingleStore's side. And again, SingleStore ANSI SQL compliant, so pretty much the same syntax that you would see in Postgres, you can see in SingleStore. Same syntax you can see in MySQL, you'll see in SingleStore. And again, low latency, high concurrency analytics with complex joins. That's somewhere where SingleStore shines. Awesome. So the last piece, of course, is the SingleStore demo. So let me go ahead and show you the where SingleStore plays a role. So I'm going to just quickly connect to my SingleStore instance. And we'll go ahead and take a look at the actual query that we're running in SingleStore. So here's the query that we're running in SingleStore, and it's achieving the same goal, right? We're doing our full text search to return relevant paragraphs with these keywords. We're doing a vector search to essentially compare to our query vector. And essentially, we're using approximate nearest neighbor indexing with IVFPQ as our indexing algorithm. Finally, we're combining the full text score with the vector score into a hybrid score that you see over here. So let's go ahead and run this. And what I'm going to do is show you what this looks like on the SingleStore side. And immediately you can see we executed 250 concurrent queries with a response time of 1.2 seconds across the 250 concurrent queries with 0 failed queries. So that brings me to the end of the demo portions. Let's recap what we've seen. Why should you use SingleStore for Gen AI applications? Well, SingleStore, first of all, is scale out. So we can handle your compute needs as you grow. We're standard ANSI SQL compliant, so you don't need to learn a whole nother programming language to query your database. We can handle transactions and analytics at scale. So we grow with you as your application grows. We can do a combination of vector and full text search in a single query with millisecond response times. And all of this happens in real time in one place. So that's essentially where SingleStore plays into this whole process. So, yeah, that's it from me. I'll pass it back to Yukti.
Really, okay, sorry. That was really informative, and we can actually, before moving forward to the next webinars, I'll actually give you some time for the Q&A session, and we can take Akmal's help as well. So for all of you those who have questions, you can see that there's a Q&A button at the bottom of your console. Please feel free to send in more questions. And we are really sorry if we are not able to answer any of your questions. Our team will actually follow up with everyone via email after this session. And I put an email address in the chat. So if anyone has any specific questions, please feel free to reach out to our team and we'll get back to you. Okay, I think Akmal, which question do you think we should take up first?
I think there's a couple of outstanding ones. Rohit, if you're able to see the Q&A, please just start at the top and work down. I'll see what I can do in the meantime to answer some of the other questions. But Vijay has a question there, if I can pick that one because he seems to be the top of my list there. He says, do you have a pointer to performance comparison between SingleStore and ClickHouse? I'm sure we do have something. I was searching a little bit earlier, but I'm not sure if you're aware of anything, Rohit, because you work with customers. So do you have any thoughts on that one?
Yeah, I personally haven't looked specifically for ClickHouse. I haven't seen it come up in Gen AI conversations that I've had. But yeah, I'll pass it back to you.
Yeah, and I think then just probably just work down the list then, please. Okay, I'm a little bit further down answering somebody's question. So Nisha's question there. So
For
I'm
sure, for
working
sure.
on one. Yeah.
So Jorge asked if the ETL process is what defines the quality and focus of my data set. Oh, wait, what happened? Okay, yeah. Can I parameterize my objectives with the data in your ETL tool? So I'm not entirely sure what you mean by this question, but essentially to answer this question, SingleStore is a database in which you store all of your data in one place. So it kind of eliminates the need for an ETL tool. So yeah, hopefully that answers your question. Let me move on to the next one. The LLM is used to translate question. Osama asked, the LLM is used to translate the question and answers into natural language. So that's a great question. So let me go back to the RAG architecture that I showed you before. It's all the way back here. So in your Gen AI application, you have your LLM. So there are two pieces to this, right? The first piece is your embedding model, right? So this is essentially how you translate your natural language into embedding vectors that essentially you can go and compare in your database. So the LLM will first convert the question into an embedding vector, right? An embedding vector essentially is like a numerical representation of the semantic meaning of any text, right? So that's the first place where the LLM is used. The second place is when you return your results from the database, for example, from SingleStore, the LLM will interpret that data as part of its context. So that gets into the whole concept of prompt engineering and all of that stuff, being able to give your LLM proper context. So for example, if you asked the question, tell me about a certain ad campaign, and it did the vector search, it returned the relevant pieces of information about the ad campaign, then sending it to the LLM, such as GPT-4, it would be able to take the text data from the ad campaign, read through it, and understand what's going on in it, and summarize it and explain it back to you in natural language. So to answer your question, there are two pieces where the LLM is being used. One is for the embedding model, and one is for the natural language responses.
Rohit, there's a couple of questions there asking about PG Vector.
Yes.
So any thoughts on that? Why those queries seem to be failing? Is it simply because of the implementation, you think? Because I know they added this kind of module that allows it to do it, but it's in my mind, it's more of a kind of a short stopgap kind of solution rather than a long-term fix, which I'm sure they'll add to the product fully in time. That's my thoughts.
Exactly. So yeah, to talk a little bit about that, and Akmal, that's absolutely spot on. PG Vector, as it stands, has a single node architecture. So that's what I meant when I was talking about MacGyvering your way into a distributed database in order to handle the concurrency requirements of your application. So if you had multiple people asking questions of your database, of course, if it's very low concurrency, maybe you had like two to five users asking questions, nothing would fail. It would probably be fairly performant as well. But as your application grows, you'll have many users using it, and all of them will have their queries hitting the database at the same time. So given that there's no separation of compute from storage or compute from compute, all of these different queries will be competing for resources. And as you saw, because of the competition for resources, some of them had to fail. So that's essentially what we saw in the PG vector case. So Donald asked how many shards is used for your horizontally scaled SingleStore implementation. So Donald, I have used an S00 instance on SingleStore. So that essentially has 2 vCPUs. Sri asked, how can we test scaling? So essentially, when it comes to scaling, there are a couple of ways you can go about testing it. There are common benchmarking data sets out there. And one way you can do this is spin up a free trial of SingleStore. We give you $600 worth of free credits. And essentially you can run your vector search queries on your test data and just keep on trying the different instance sizes. So, go from S00 to S0 to S2 to S4 and so on.
Yeah, I can just add there that I think I've been with a company almost 3 years, and I've typically used S00 for most of my demos, and it works well. I mean, okay, it's a kind of 2-node kind of architecture, right? 16 gigabytes of RAM. And by the way, if anyone's interested, there is the portal, portal.singlestore.com. So if you sign up following the link that Yukti provided and you've created an account, there's a left nav in the portal. Right at the bottom, there's a section that allows you to get a license that allows you can use to install a 4-node version wherever you want, on-prem, in the cloud, wherever is convenient for you. And it's the full product, and it's not restricted in any way other than the fact that there's only 4 nodes. Okay, so if you want to try something for yourself, but the cloud version is the quickest and easiest way, because there's nothing to install, nothing to worry about. If you got a browser, you can do stuff. That's the real sort of advantage and beauty of it.
Awesome.
Right. So I think you answered that question by Jorge. That one. And
can I just tell about one question?
Yeah.
Rajesh says that what about tensor search using SingleStore? What are your comments on this?
Oh, that's an interesting question. I haven't actually haven't come across anybody trying to do tensor search. Yeah, I don't think we have tensor search in SingleStore. But I'd be interested to hear about like why that's a requirement for you.
Thank you.
Awesome. So let me answer the question by Mogit. So yes, essentially we have used the base version of all of the managed services from MongoDB Atlas to Pinecone, and that's definitely one of the key causes of the latency for the different pieces that you saw there. Again, so like I mentioned, SingleStore out of the box can handle your concurrency requirements, and again, we can scale up as those requirements also scale up.
Yeah, there's just a quick question there from Osama was asking, did I understand correctly? The LLM is used to translate question and answers into natural language. Well, the thing is, what you typically do, as Rohit was showing with the RAG app, I mean, you're kind of augmenting the knowledge that the LLM has, and you're asking it some questions, and it can summarize the results for you. It will present those back to you. Typically, if you want to work with something like an SQL database, and SingleStore is a great example. LangChain is awesome. There's some specific tools and chains that you can use, so you can actually formulate your queries in natural language. It will convert them into SQL statements for you and return results for you in English. I mean, that's probably the simplest way that you can get started. Literally, it's like a couple of lines of code, and that's the best way to get started. So you don't have to have specific natural language capability, or in terms of the LLM, obviously, it needs a prompt. It needs a particular representation that it's going to work with, and it sends you back an answer, and you can interpret that. But yes, that's probably the quickest and easiest way I would suggest.
Awesome. Thank you, Akmal. Let me answer an interesting question by Sandeep. So Sandeep asked, does SingleStore support metadata filters and fuzzy queries similar to Elastic? So to answer your question, Sandeep, 100%. When it comes to metadata filtering, essentially, let me go back to the SingleStore query that we had. This full text search over here comprises of a CTE in which we are doing a filter over the paragraphs for the specific phrase AAA games. So essentially, what this means is you can plug and play any sort of metadata filter that you wanted into the CTE. This is just a simple example where I've chosen to do a full text search. Now, given that SingleStore has an implementation of the Lucene library, you are absolutely capable of doing fuzzy queries similar to Elastic.
Yeah, and I think for the full text, which we've had the built-in Lucene engine for some time, the next major release is going to have the Java version. I believe that's going to be even better. So something to look forward to.
That's correct, yeah. So Bonnet asked, can you use SingleStore for function calling with arguments found on APIs? So SingleStore can be used for function calling, but I think for the second part of your question, I definitely would like to know more about that. Arguments found on APIs.
Oh, there's a great question here, Rohit, from Kashyap, who's asking, is SingleStore providing any embedding model like Amazon Bedrock Titan? If you have been a regular with these webinars, you know that there is a technology out there called Ollama, which allows you to run LLMs locally. And we are no promises. Okay, I said this before. Okay, it's always difficult to make these announcements, and then people say, "Right, you said that we're going to have this release," but we're looking into this. Okay, so that we will actually host these within our environment as well. So you can, choose a particular LLM of your choice. You can have it installed within the environment, and use it as part of the compute service. And that's great, because then you can essentially run it with your preferred language model. And in terms of the embedding, it's actually no problem. It's very, very simple. So generating the embeddings, you don't actually need an LLM for that. Sometimes the data occur naturally in a format that you can use. So think, for example, there's a particular data set. Name escapes me for the moment, but it's like 60,000 items of clothing, okay? And this is like 25 or 26 pixels by 25 or 26 pixels, okay? So each one has a particular sort of gray setting, right? And there you've got just need to flatten that out, and you've got a natural kind of vector representation. So you can just store that without having to go through the LLM. And remember that SingleStore, as Rohit showed, I mean, there is a vector type, data type that can store. You can provide it with the number of dimensions of the vector, the embedding that you want to store. Once it's in there, you can query it using Euclidean distance, cosine similarity. You can code that up, dot product, whatever is your choice. In fact, Yukti mentioned a couple of the webinars. I think I've got one coming up in the very near future where I'm going to be presenting Ollama, and we're going to look at embeddings. We're going to look at running it locally and connecting to SingleStore in the cloud, or you could run SingleStore locally as well. It's entirely up to you. And this is a major concern, I think, for some attendees that we get, because this issue of sending your data to a third party so that they can generate the embeddings for you, or you're asking the LLM, for example, there is a need to have greater control of that, be able to put that behind the firewall, run it in your own environment. There's a couple of ways you could do that. With Titan embeddings, AWS, I mean, it's awesome because you could create something like a virtual private cloud. You could SingleStore is in the AWS marketplace as well. So that's a great way to, again, have some control in terms of where things run and who's able to access them. And I think those would be a couple of different solutions that you could use in that scenario. Okay, let's see. Ming's got a great question here, Rohit. I think you mentioned this already. It says, can you define the vector index for the vector store? HSNW, I always get that wrong, IVF, etc. I think you briefly alluded to that and mentioned that already. So
Yeah, 100%. So when you're at the table creation time in SingleStore, you can define you can define a vector index. And again, we have multiple different options for you. We have an implementation of the FAISS library, the FACE library. And yeah, essentially you can define your IVF index, IVF flat, IVF PQ, IVF PQ fast scan. You can define your HNSW indexes as well. So we have HNSW flat and HNSW PQ. The recommended indexes that we have are IVF PQ fast scan. This is optimized for speed of retrieval, and HNSW flat, which is optimized for precision or recall. But both are highly performant. And in fact, we recently released a blog in which we, perform benchmarks on our database, and we compare it to a bunch of other vendors as well, especially for our indexing.
yeah, I think the results of the blog actually showed that we are competitive with the pure vector database. And that's only going to get better because engineering is working on lots of improvements as well and behind the scenes. And I expect great things for the rest of this year. I think watch this space.
Yep, 100%. And this is the direction that these RAG applications are going. To have such a complicated architecture is not in fashion much anymore. So because we have comparable or better performance with a lot of these vendors, it essentially comes down to, how much data are you willing to store in one place? Um, let's see.
Anything else caught your attention there, right? Any
Yeah,
other?
just looking through some of the questions. So let's see. So I think Rutvik, you had a great question here. How do we query the geospatial data as a single store data source? So again, when it comes to geospatial data, we have a bunch of different native functions in SingleStore that allow you to query this data. We have the geography point data type, as well as some indexes that allow you to quickly filter through your data. But we also have a bunch of native functions like Polygon and so on that allow you to query the data and filter through it as well. Let's see. Yeah, I'm to Carrie, to answer your question. I thought I did send the link, but it doesn't look like I'm able to send it in the chat. Yukti, do you mind if you can send
Sure
the
thing.
blog
I'll
link?
just
Thank you so much. I think it's because I haven't signed into my Zoom. Oh, Osama has another great question. Talking about knowledge graphs. So again, like Akmal said before, watch this space. We will have another live webinar upcoming soon. Essentially showing you how to create and store knowledge graphs in SingleStore, how to query them. And we'll also have another post on our blog about that soon. So again, watch this space.
We have one very interesting question. Ming Zheng asks, we currently use Pinecone plus Mongo like the demo you have shown. And what is the customer experience of migrating to SingleStore from either Pinecone or Mongo?
That's a great question. So when it comes to these Pinecone plus Mongo deployments, generally one thing I've seen is that people are fairly happy with their application architecture. The only problem starts coming in when they're trying to do analytics on, for example, their chat feed data, or if they're trying to build some sort of analytical filter on top of the data in Mongo. They're not capable of doing the analytics in these NoSQL databases today. So essentially, that's one of the reasons why we have SingleStore Kai. It connects natively to Mongo. It allows you to query your data and run analytics in real time as compared to the experience that you'll have in these NoSQL databases. But on the other hand, when it comes to migration of that architecture to SingleStore, they're able to generally get better performance, which is more scalable, and yeah, they're pretty happy with their choice in moving.
Yeah, that example is actually interesting because we have the Dummies book that we published last year. I think it was in October, sort of time frame. On our website, the GitHub repo, there is an example notebook that actually uses both Mongo and Pinecone and shows you queries, a kind of a problem, if you like. And it's actually a chapter in the Dummies book as well. So it discusses the issue of like having two separate systems, one to handle vectors, one to handle your documents, and then some of the issues around that, how you could move that across to SingleStore, because we support both of those capabilities. You can store JSON documents and you can store vectors, and so you don't now you've immediately cut the number of technologies from 2 to 1. And it does both of those things. So for the business crowd, that's great. You reduce your total cost of ownership, you improve your return on investment. If you're a developer, and I know how painful it is these days, learning so many technologies, and the pace of change, as Rohit mentioned, is so fast that you can't, almost difficult to catch your breath because something new is just around the corner all the time. But this gives you the opportunity to use a product that can do a wide range of capabilities beyond just vectors and JSON documents. Geospatial was already mentioned, time series, full text search. We do both OLTP and OLAP. And the product is used by over 350 global corporates, companies around the world. So all right, I think there's way too many questions beyond what we'll have time for.
Yeah.
We have a very interesting question from Praveen. He's saying that you mentioned SingleStore is a vector-capable SQL database. How you process non-structural data for retrieval?
So that's a great question. So for example, if you were talking about text data, the typical kind of procedure that people go through is application side, they will chunk their data into chunks based on what type of retrieval they want, what level of retrieval of information that they want, and they'll insert that into SingleStore, essentially into one of their text columns. So that's essentially how they would process the unstructured data in SingleStore. Now, again, alongside that text data, you'll have your vectors, you'll have your IDs, maybe a timestamp, and so on. So all of that can be stored alongside each other. And on that text column, you can again build a full text index and run your full text queries.
Yeah, and I think just on the JSON thing as well, Rohit, I remember almost kind of this time last year, I think it was, the JSON, because SingleStore's had JSON support for some time, so that if you've got documents, for example, which can be variable in size, not quite the same thing as fixed kind of relational tables, it becomes a little bit of a challenge. But JSON storage has been there for quite some time, and it improved significantly last year. I actually showed a demo of the old way that we used to do it versus the new way we used to do it. The new way was almost instantaneous. Literally, you just hit the return key, the answer comes up. The old way, you could go and make a cup of coffee and come back, and you know, so there's these improvements all the time that can help. But as you were saying, the full text, again, you know, combined with the unstructured data, say JSON, for example, geospatial, time series, lots of possibilities in terms of how you could query your data and the multitude of data types that you can work with. You see anything else interesting there? That's
Yeah, I actually see some questions.
Yeah.
So Donald asks that, so two virtual CPUs were able to handle 250 concurrent queries in almost 0 seconds with no loss failed queries. He's saying that I'd like to understand what the horizontal scale of this demo looks like, and also how changes that to the scale changes to the scale affect the performance.
Yeah, of course. That's a great question. So essentially, when we had basically 2 vCPUs for our workspace, and running these 250 concurrent queries took about 1.3 seconds. So that's kind of what we mean when we say this was the horizontal scale of our data. But you know, if you want to know like more details about this, essentially we can send you more information about how SingleStore works under the hood, how we deploy our master aggregators and leaf nodes and so on.
Yeah.
For queries like these, you guys can reach out to our team. I've put the email address hello@singlestore.com. You'll have a lot of time with our experts, so these things are better explained over there. We also have more interesting questions. Mogit says also insights on air gap deployments capabilities of SingleStore. What's your comment on that? Do we have air gap deployment capabilities?
Yeah, for sure. So when it comes to kind of spinning up your SingleStore instance, let's say you go with a cloud deployment, this will be deployed within SingleStore's tenancy in whichever cloud provider that you want. However, if you had stricter security requirements, SingleStore can be deployed on-prem in an air-gapped manner as you require.
Okay, that sounds
So
really
you,
good.
you would have to provision the compute resources for your SingleStore instance, but you would install the software on all of your compute resources.
I think you shared the link to Rohit's notebook already, haven't you? It's in the
Yes,
chat somewhere,
I have.
in case
Yes,
people.
I have.
And so people are very welcome to try out Rohit's demo themselves and see how it goes. I assume there is. I mean, if it's being run in our notebook environment, Rohit, I mean, obviously it's a no-brainer in terms of provisioning the compute resources for us. But you'd need to connect, I assume, to your Postgres or your wherever your Mongo or Pinecone are running.
Yeah, so you would need your own need your own Postgres instance, you would need your own Mongo instance and Pinecone instance. And of course, I encourage you guys to try and break each of these instances as much as you can. Definitely don't take our word for it. Go in there, break it, test the limits of the capabilities of each of these systems. Because at the end of the day, you're building an application for yourself. So you need to choose one that works for you. Now, my recommendation, of course, would be SingleStore, given our capabilities to scale up and scale out, given our vector search, our full text search, all of the different pieces that we've built out over the years. But again, go ahead, evaluate it. I'm sure you'll come to a similar conclusion.
Will asks, wanting to integrate AI from the inception, can I integrate Vertex AI and Fabric Azure projects? Looking for least latency NLP. I think this is a great question. You can answer this very
Yeah,
well.
that's a good question. So I do know that SingleStore can integrate with Vertex AI. The specific deployment options and integrations would probably require a much more in-depth conversation. But yes, SingleStore does integrate with Google Vertex AI.
We actually have some content on Google Vertex AI. We have had some webinars, like we can actually provide them if the link is not there. You can all reach out to our team and we'll be good to go actually. Someone asks, Chitali asks, how to use SingleStore for multi-agents?
That's a great question. In this case, I think SingleStore would to go back to these types of applications. Sorry, let me just quickly skip through this. To go back to these types of applications, SingleStore essentially functions as the memory layer for your Gen AI application. So it serves as either so it works as the store underneath. So your agents will be able to access that data and retrieve information and execute different actions based on that information. So that's how SingleStore works with these multi-agent architectures.
Again, we have content on this as well. You guys can check out our website, and we do webinars regarding so many of these topics, and your questions are such an inspiration for us. Please keep these coming and we'll come up with more and more content. We have some questions regarding, how SingleStore is comparing with different databases like Milvus, Google Spanner. What is your, do we have some documentation on these databases?
I'm not sure about the specific documentation per database. The one that I've seen specific to the vector functionality, was the blog that I shared earlier. But with regards to Google Spanner or any of the other ones, I haven't seen anything specific.
You guys are, welcome to try it out. We have the link to the notebook in the chat, and if you guys find something interesting, you can reach out to any one of us on LinkedIn as well. We'd love to hear your feedback. Okay, we can move on to the other questions.
You might want to do the draw soon. I think we're at time.
Oh,
so
yeah, we actually have. Okay, we'll
I
follow
could
up with
spend hours
everyone.
here.
Yeah, that means an overwhelming response. Thank you so much, everyone. This really means a lot to all of us. A lot of effort goes into these webinars and, putting together all the content. Okay, so the announcement that you guys have been waiting for today's raffle winners. So, but quick notes before that. Thank you, Rohit and Akmal, for, addressing all of us. And you guys did a tremendous job with the questions and the demo. This was really interesting. So just a small reminder, Rohit, can you go back to the slide where the webinars are listed? Yeah, thank you so much. We have several amazing webinar sessions that are coming up that might be interesting to you guys. You can scan the QR code that is available on the screen. On May 15th, we have Zapier Central plus SingleStore full RAG agents. This might be helpful for the folks, those who had questions regarding RAG. And then we have on May 16th, we have Beginner's Guide to RAG with Professor Tom Ye. He is a great expert, and you guys should definitely come to see if you guys want to learn more about RAG and start from a very grassroots level. And on 22nd of May, we have LLMs in fraud detection model comparison. Akmal's webinar is on the 20th. I have put the link in the chat where he will talk about Olama, and yeah, I'll definitely encourage you guys to please RSVP right now, and we'll all hope to see you guys there. So the announcement you guys have been waiting for, today's raffle winner goes to Dinesh Selvaraj. He's a senior partner solutions engineer at PayPal. Congratulations and thanks for joining. And if that's not you, please don't give up. We are going to announce one by for anyone demo during our webinar and has signed up. You guys can be eligible and be entered to win. And I thank you, Rohit, for today's presentation and demo. Thank you, Akmal, for addressing all the questions. And thanks everyone for joining. We really value your time and energy. Please connect with us. Let us know if you guys have any feedback. And you're welcome to try out the code yourself and just play along with SingleStore and compare how it compares to other databases. Thank you so much for joining and have a great rest of the day. Thank you so much. I think we can wrap this up now. Okay. Bye.
Bye-bye.